Okay, hi everyone. Welcome back. Let's take a look at problem 4, which says find the perimeter and area of triangle ABC. Well, in order to find the perimeter, we need to know the lengths of all three sides. And so the length of side C, which we'll call AB, and so that distance, you would do x2 minus x1, the quantity squared, plus y2 minus y1, quantity squared, and then take the square root, and you get about 10.0498 and so on. Okay, BC, you would do the same thing, and you would get 13.6014 and so on. CA, do the same thing, and you get about 15.2315. Okay, so the perimeter, you would add all three up, and you'd get 38.8828 and so on units. Well, I forgot to find the area, so I squeezed it in over here. If we know the lengths of three sides, we can use Hero's formula. So I added the three together, divided by 2, and I got 19.4414 and so on. And then I took the square root of s times s minus the square root of 101 times s minus the square root of 185 times s minus the square root of 232, and I ended up with 67 square units. So I apologize for squeezing that in over there real small, but there it is. We've used the Hero's formula a million times before, so I'm confident that you'll be okay. Okay, this next one. A pentagon is inscribed in a circle of diameter 12 inches. Points E and C lie at the ends of the diameter. So EC would have a diameter or a length of 12 inches. DE is congruent to DC, and EA is congruent to CB. The measure of angle EAB is 129 degrees. Find the length of DE, the measure of angle EDC, the measure of angle DEA, the measure of angle DEC, the area of triangle EDC, and the area of the pentagon. Holy smokes, there's a lot. Well, if we look at this bottom part, we have an isosceles trapezoid because these two sides are equivalent, so that makes it an isosceles trapezoid. So that means these two angles are the same. Okay, so now if we look at the top, we have a triangle, and one of the sides is the diameter of the circle, and the opposite point lies on the circle, so that means this opposite angle is a right angle. So we can use the Pythagorean theorem. If we call this side x, this side will also be x because they're congruent. So x squared plus x squared is equal to 12 squared. So x is the square root of 72. So that means DE and DC are both the square root of 72, which is approximately 8.4852, and so on. Okay, so one of the angles they asked us for was angle EDC, and we said that that was 90 degrees. And angle DEA would also have to be equal to angle DCB, because these sides are congruent, these sides are congruent, so that forces these two angles to be equal. Okay, so how do we find those two? Well, if we think about it, if we add up all the angles in a pentagon, then they are equal to 360 degrees. So angle A plus angle B, angle C, angle D, and angle E all add up to 360 degrees, while angle A is 129 degrees, angle B is also 129 degrees, angle C is what we're trying to find, angle D is 90 degrees, and angle E we're also trying to find. And so that's equal to 360 degrees. So subtract the 229 degrees from both sides, subtract 90 degrees from both sides. You get C plus E is equal to 192 degrees, but C and E are the same. So you can divide both sides by 2, because these are 2 angles, and both of those angles would have to be 96 degrees. So it wants us to find the area of triangle EDC. So EDC. Okay, so the area of the triangle we know is 1/2 the base times the height. So if we call this the base, then this would be the height. And so we found that that was equal to the square root of 72. So we'd have 1/2 the square root of 72 times the square root of 72, which is 36 square inches. Okay, so the last thing they want us to find is the area of the entire pentagon. Well, we know the area of the triangle, so if we find the area of the trapezoid, we can add them together and we would have the area of the entire pentagon. Okay, well, what can we do? I redrew the circle over here with just the pentagon. And we knew these 2 angles were 129 degrees. And we found that this angle here is 96 degrees. Well, if this is 96, if we look at the triangle, this is 90 degrees. These 2 angles have to be the same because they're opposite equal angles. So we have a 45, 45, 90 right triangle. And so if this whole angle is 96 degrees and that's 45 degrees, that means this one's 51 degrees, and same thing over here. This has to be 51 degrees. So when I drew my trapezoid, I put the 51 degrees in here, and then I drew 2 radii. So this radius, is half of 12, so it would be 6. Same thing with this radius and this one. So what I want to do is draw the height, because I need to know, in order to find the area of a trapezoid, I need to know the height and then the 2 bases. So I took this little triangle right here and drew it over here. But we need to know this angle. Well, if I look at this triangle here, we have an isosceles triangle. So 2 sides are the same, so their opposite angles are going to be equal. So this would be 51 degrees. And if this whole thing is 129 degrees, then this would have to be 78 degrees. So if I draw this triangle over here, this angle is 78 degrees, this side is 6. We need to know the height for the height of the trapezoid. And so sine is opposite over hypotenuse. So sine of 78 degrees is h over 6. Multiply both sides by 6. And I end up with 5.8688 and so on for the height of the trapezoid. Okay, so now we need to know this base. Well, this triangle here is the same as this triangle. And so if I call this H and this H, then the whole base would be 2 Y's. So if this is Y and this is Y, then the entire base would be 2 Y's. So to find Y, that's our adjacent side. So cosine of 78 degrees is adjacent over hypotenuse. Multiply both sides by 6. we get 1.2474 and so on for y. But our base is 2y's, so I multiply by 2. So now we know our height, we know the smaller base, the longer base is 12, so we can find the area of the trapezoid. So area of the trapezoid is 1/2 the height times base 1 plus base 2. So 1/2 the height that we just found up here is the 5.8688 times the smaller base, which is the 2.49 number, plus the longer base is 12. Whoops, type that all in the calculator and we get 42.51348 and so on square inches. Okay, whew, that's done. So the area of the pentagon would equal the area of the triangle plus the area of the trapezoid. So 36 plus the 42 number, we get 78.5345 and so on square inches. Whew, what a problem. Okay, so please go ahead, take a look at the homework, and let me know if you have any questions. Have a wonderful day.